Uh, we have Mr. Ramesh Narayanan. He's the CEO of BSES Rajdhani Limited, and he's going to present his perspective now. I'll call him on stage. Thank you.
Morning, everybody. So I think after the awards session, most of them have gone for a celebration, it looks like. So there are very few people left in the audience. I have a very brief presentation, a small correction on that introduction. I'm CEO of BSES Yamuna Pal Limited. That's Rajdhani is another group company of ours. So I supply electricity in East and Central Delhi. And I have here with me a very brief presentation, in which I would like to provide, provide a little overview about the Indian power sector, and then like to give a little highlight of what did we do to turn around the Delhi power distribution companies, and then what's the role of IT in this entire change management. So, on the power scenario, India, we introduced electricity way back in Delhi in 1905. In the world, it came into existence in 1882 in New York and about 1888 in London. And so we were not very far away. In 1905, electricity came into existence. From 1905 to 1947, till we achieved independence, we added about 1400 megawatt. And from 1948 to 1991, we had this from private sector when we achieved independence. Most of these generation and transmission distribution facilities were with the private hands. Then we moved to a state utility controlled kind of era from 1948 to 1991, and we added 64,600 megawatt in that 43 years. Then the reform was introduced by the current Prime Minister as the then Finance Minister way back in 1991, late part of 1991, early 1992. And in 20 years' time, we have added about 135,000 megawatt. That's about 213% growth. So what did we do that which enabled such a phenomenal growth in the generation side? The liberalization policy brought in certain enablers. It was essentially focused on accelerating development in the sector, and it provided an easy avenue for foreign direct investment. But when we compare our performance with China around the same period, China in 1991 had about 150,000 megawatt. Their grid demand was about 25,000 megawatt. And in India at that time we had about 66,000 megawatt. Our grid demand was 57,000 megawatt. And in the last 20 years, our demand has doubled. Whereas in China, their demand has multiplied 5 times. They have installed capacity of 9,50,000 megawatt. They have a grid demand of close to about 7,40,000 megawatt. And we have an installed capacity of close to about 2,07,000. Currently, I think it's 2,10,000 megawatt. And we have a grid demand of about 1,25,000 megawatt. And you can see how these growth comparison directly impact the economic development of the respective countries. You can see the GDP, you can compare the growth of the GDP, and you can see the per capita GDP and the average gross salary of the people. Everything seems to be closely linked to the kind of growth which has happened in the power sector. Today, when we see on a global ranking basis, India is somewhere 5th in the world. The largest in terms of installed capacity is USA, followed by China. Then you have Japan, Russia is 230, and India is about 210,000 megawatt. So we are 5th, but maybe by end of the 12th plan, we would be probably the 3rd in the whole world, based on the kind of capacity which are getting added. So what were the enablers which was introduced way back in 1992? You had some administrative framework. That's, they sized up all the kind of clearances which are required for a project, and they created an investment promotion cell, and a time-bound clearances were all provided. They enabled they provided some good legal framework. Our arbitration clause were brought at par with Ancetral, and they enabled foreign direct investments. And in financial framework terms, they had those special purpose vehicle which was allowed for project financing in generation side. You have an assured return on return of equity. Then you have a two-part cost reflective tariff. Then you have incentive like tax holidays, some concessional duties, and some tax waivers. All this helped. So, and how did this bring about change? So in 1991, the private participation in the generation was just about 1%. And in 2012, the private participation has grown to almost 28%. So that's the kind of phenomenal confidence the private sector showed, and then they invested profusely in the generation sector. Now, when you invest on the generation side, unless you make a matching investment on the transmission and distribution side, the power really doesn't flow to the end user. So you see on the 12th plan the growth in the private sector in terms of investment. We are planning to add about 88,000 megawatt on the generation side. The growth is likely to be about 57% of this investment is going to come from the private side. And similarly on the transmission side, there's going to be investment closely to the range of about 2,50,000 crores. And on the distribution side, you need about 4,30,000 crores. Now, both the generation and transmission, they are the investment happens on project finance basis. That means the revenue generating contract, like a power purchase agreement in case of a generation contract, or in case of a transmission business, it is the bulk power transmission agreement, which are held as collaterals. And so whereas in a distribution business, your strength of the balance sheet dictates the ability to mobilize fund in that sector. So that's the biggest constraint as far as getting that infrastructure up on the distribution side. So unless the distribution infrastructure comes up, you can't have all this power capacity which has been created flowing to the end user. So that's the biggest challenge. And in the distribution side, it's not that if you create 1 megawatt of generation, that all that energy would flow through that same transformer. So you have to create a whole lot of redundancy. So the ballpark is about 2.1 times that capacity in generation. To create that much capacity on the distribution side depends on the diversity factor and the kind of geographical spread. So that's another big challenge. So and on the distribution side, currently there are just 4% of the entire license area is in the private hands. 96% is still government control. And so this 4% is predominantly in urban areas. So and you have and rest of the place, it's all with the state utilities. So as far as DYPL is concerned, this experiment started way back in 2002. We distribute in a very small license area of about 200 square kilometers. We have about 1.2 million customers. We have a customer density of almost 6,000 customers per square kilometers. Our revenue, I think it's an old number there. The revenue is more than 4,000 crores now. Input energy is about 620 crore units, and peak demand 1,461 last summer, and energy build and we have a loss 17.8. We started off at 63, which has come down to 17.8. It's unprecedented, and we achieved this accelerated reduction in AT&C losses by a whole lot of IT engagement. So what did we do first? First, we debottlenecked the system. We invested on the assets. We made them operate. We operationalized assets. So wherever we had bottlenecks, we just debottlenecked the system. So we invested close to about 2,000 crores and made the system deliver power. Normally in this sector, people retire, equipments don't retire. We wait for it to, collapse. So we started doing some residual life assessment, and we started, retiring equipment, phased out all those outlet stuff, and put in state-of-the-art equipment, and that made the assets operable. We worked on a whole lot of technology. We brought in, typically in the power sector, people would sell specific products, but not solutions. They would do the jigsaw puzzle on the field. They would buy a transformer, they would buy a ring main unit, they would buy an LV equipment, they will then talk about communication, they will have some smart meters, and then they will do all that assembling work on the field. Whereas, you don't go and buy a tire and an engine and a body of a car and then assemble it. You just go to the showroom, pick up a car, and you expect to drive out of the showroom. But in the electrical industry, we buy all that and do the jigsaw puzzle on the field. So we got to move to this kind of a solution approach. We got to have everything packaged there and brought in. So we started working on such package substations, and we eliminated all those 7 and 4 panel boards and brought in ring main units. We went for high voltage distribution system, but still a long way to go, because we have worked only on the hardcore electrical systems, but not integrated it with the IT solutions. So, but still this had to be done. So all this technology were done. You could see typically an old transformer would look something like that, and a new package assembled in the shop floor control condition would look something like this, and with all the required paraphernalia boxed up inside that. So it comes, you just establish a plinth and put it there, and it's boxed up, it's safe. Even if there is an explosion, a child standing next to it is not supposed to get hurt. That's the kind of norms which are followed, and so similarly a whole lot of new culture and a new approach had to be introduced. That's how the old panels used to look. Now it's all being changed to RMUs, SF6 breakers. So even these are obsolete. Then we found that the organization was too generic in nature. So from a generic organization, you got to go on to specific core competencies. A chief engineer was responsible for everything, including IT, including legal, business, O&M, whatever. So we had to segment them functionally and then create organizations which would have core competencies. So we worked on those areas. From a generalist organization, we worked on the specific functional organizations and then created core competencies. The moment we moved into that kind of a segmentation, we found that you have created silos. And how do you integrate these silos? So that's where we brought in technology, IT, and IT on the system operation side. We used SCADA, we used distribution management system, we had OMS, outage management system, GIS, then smart substation management system or smart grids, all this on the operational side. And on the business side, the meter to cash was completely automated. The consumer customer assistance systems, the interactive voice response system for customers, you have all services provided through the web-enabled system. Then the metering, we had remote metering, smart meters, prepaid, energy audit, AMI, all these technologies were introduced. Then you had common services which would integrate all these functions through a SAP, and through the SAP and even the common services like admin, legal, call center, all that was IT enabled. And communications was essentially through Lotus Notes, cell phones, mobiles, and we used all kind of communications, VSAT, GSM, CDMA, AMR, fiber optic, and you had to now change the workforce, bring in extremely IT-enabled team to provide both the back end and in some cases even the front end support for this kind of a technology movement. Then the next issue is we had to work on strategies. There were a number of strategies which we were working on parallelly, so we had to prioritize. One of the major strategy was reducing AD&C losses. So 100% of electronic meters helped us. Every single meter is downloaded using a common meter reading instrument or a remote meter reading. So that eliminated human factors. And they would come and upload the data on the system. The bill would automatically get generated, would get posted in the website, or could be sent through an SMS or an email, or give a physical copy because the act demands so. So all that was possible. So the revenue realization, every single bill was barcoded. So we capture that they would get rightly posted onto their accounts. It all sounds very routine, but to manage in millions of people and deliver it consistently is a big challenge. And I tell you, probably I was very recently in Geneva, and I didn't find all their meters to be static meters. Whereas in Delhi, in VYPL and BRPL, we have 100% static meters. All the meters are downloaded. So it's not somebody just goes there and notes down reading and makes some mistakes, either parallax error or some human error. All that's avoided. It's technology. Similarly, on the quality of supply, voltage stabilization, reactive power management, reduction in load regulation or shedding, whatever you call it, all that was possible using technology. And we could do it remotely. The cost of supply, we could optimize in terms of scheduling of power, the power management, forecast the demand correctly, schedule the power based on merit order dispatch, and then bring down the input cost. And if there is a outage somewhere, the least cost options was taken. What is the best way to backfeed that area? So all that was done. Scheduling was a very important factor which helped to contain cost. So these are some of the factors which were not being practiced typically in any utility before. So all these technologies have been introduced. They would do it manually, and once they have set that scheduling, they would follow that for all time to come. It was not a dynamic system, and here it's a dynamic system, real time. The customer care, everything was enabled. Why should a customer come to the office to get everything done? So we would send people to their place. They could drop their bills wherever they want, could pay in umpteen options, either using credit card, through the web, whatever. So all those options were brought in. So we had to ensure reliability, faster response time, and for employees, you see, this sector, you have the highest man megawatt ratio. If you typically look at the power sector, we use a jargon called man megawatt ratio. So in a generation business, for every megawatt, you have roughly about 1 man per megawatt. And in a transmission business, for every 10 megawatt of power which you are transmitting, you use about 1 guy. But in a distribution, it depends on the geographical spread. It could be anywhere between 5 to 15. In a concentrated area like mine, I manage with 5 men per megawatt. And if it is going to be a state like Uttar Pradesh, where a 200 kilometer away you have some customers, so you got to have someone close by to attend to his problems and sort out his issues. So there are going to be much more people there if things are not IT enabled. So you will have more people there. So then the service variability depends on how do you bring all of them at the same level of competency. So that's a big challenge in a distribution business. It's not just technical ability, it's also the ability to handle customers. They would be breathing on your this thing, because they are going through some challenges, and you got to deliver power immediately. Whereas you will require certain time to attend to your devices. So how do you balance this? So both technical skills and the soft skills equally important. And in this business, you don't have a simulator. And distribution business, there were hardly any research and development going on. So all these things were very crucial. So we worked on these areas, and today we have developed a simulator. We have patented it. It's called Drona. We have smart substations. We have patented it. It's called Midas. We have worked on a whole lot of renewable solutions. So all that has happened. I'll be covering it in the subsequent slides. So I told you about the Midas. Midas is something like, if you look at typically in a distribution business, when the power goes off, we call up the utility, and then the utility gets into action. So they're always on a reactive mode. So we wanted a paradigm shift. We said, look, we got to know the problem before the customer comes to know of it. So we developed this solution with the help of IIT. We defined our problems. They took a lot of young engineers from us, and the professors trained them up. They designed the circuits. They put in those instruments. They wrote the firmware, all the applications, patented it, did the pilot, worked, and now we have scaled it up. We're doing it across the company. What it does, it constantly monitors the substation, and it finds out whether the health of that substation is okay, whether the transformer is overloaded, or the oil levels are fine, or the leads are getting hot, or if there is any intruder there, or the gas pressure in the breaker is okay, or if there is a fault path indicator, what is the direction in which the fault has happened. All that it continuously monitors. Or if there is going to be some kind of a fire, if it gets hot, the IR radiations, infrared radiations, it captures. And it compares with the reference. The moment it goes beyond a defined parameter, it sends an SMS to the lineman. It's continuously updating on your server, the data. So the moment that guy receives an SMS, it also sends an SMS through the SAP to the store to keep the material ready. So this guy goes there, picks up. If he's carrying an Android phone, it gives him the shortest route to reach to that location. So he lands up there, fixes the problem, doesn't have to make any report. The SMS from the substation directly updates, look, the problem has been fixed. Now the outages has been avoided. You have fixed the problem before a business interruption. So all that has ensured a reliable supply. Your turnaround time has come down, your response time has improved, and there is no business interruption. So this is our way of defining a smart substation. This is what we did, and we have patented it. We have done it in about 23 substations so far. Now it's proved to be very successful. So we are scaling it up. We are putting it in all our 2,250 substations in BYPL, and also in 9,000 substations in DRPL. And we're going to take this technology to Bombay, and we've already received a lot of inquiries from, say, Punjab, Uttarakhand, and other states. And we are exploring in all that place. It works on GPRS route. So this is the basic configuration. It has ability to communicate in all the 4 sides. It also remotely reads the meter. The FRTU is a homegrown product. So this is how it works. It monitors the ring main unit, it monitors the transformer, it's like a data concentrator. So it's communicating everything through that. So it's two-way. This product with a little adaptation can work even in all that communication towers where they have those DG sets and backup power. It can very well work there. It can control on the oil which has been consumed by the DG sets. It will constantly monitor whether the power was really out or in, and then it will help save a lot of oil for those companies. So we are helping some of them. So it works, and extremely cost effective condition monitoring. It moved from a preventive approach to a predictive approach. Well, it's continuously monitoring the condition. So the meter data is constantly uploaded. There is an intrusion management. real-time data, automatic notification of alarms and escalations, is an inbuilt SMPS, so the cost-effective 2 analog input ports, 14 digital input ports and 8 digital output ports, provisions to integrate with smart meters, low power consumption and designed to work in harsh environment. So some of the screenshots and advantage which I have already explained to you. Similarly, on the end user side, typically when we entered this field, we found that most of the utilities, they tend to segment their consumers into 4 categories. They say domestic consumer, commercial consumer, industrial consumer, and then agricultural consumers. But in an electricity industry, the electricity does not see its end users in that perspective. If you look at it, all these consumers effectively use electricity for just 4 applications. They use it for lighting, they use it for heating and cooling, they use it for pumping, they use it for some traction or drives. Now we started finding out what is that best energy source to meet each of these end use applications. And we also wanted to know what load, what application constituted most of this load. To our utter surprise, we found that the pumping load constitutes more than 50% of our grid load. The next load is, the heating and cooling load, which could be seasonal. Then the traction and drives. Last is your lighting load. Now, so first we started attacking on the pumping load. The agricultural farmers use it for, all their horticulture work. Then you have this, every household uses it. You have the petrol pumps, they use pumping for gas into your car. So we then felt that a renewable energy, a solar pump, can replace all this and save a lot of energy in the sector. So instead of generating electricity out of solar and then using it in a conventional way, we directly use solar energy, pump that medium, store it. It's cheaper to store water or gas or whatever, and then use it as and when you want. So we developed a product like that, patented it, and this product has proved to be an extremely successful one, and we've implemented in various schools, parks, some farms, and it's really picking up. And we wanted to make it a kind of a most user-friendly machine. So we said, what does a end user expect? He wants that, what does this machine guarantee? It guarantees, the smallest version guarantees about 28,000 liters of water a day. And it can pump up to 90 meters of height. So that's how we said, this is what it will guarantee. So it's much easier that way. And this is how the pump looks. And it's already, these are real pictures at various locations. So this is there. And last January it was launched by the Chief Minister. And it was very well received. And not just in this country, but all over the world, including the House of Commons in UK. So with this, I just wanted to give you an overview about the sector. If you have any questions, I am willing to take. Thank you.
Hello. Good afternoon, sir.
Yeah.
It was a very good, informative lecture from you. I just wanted to know one thing, that we understand that when you have taken over dailies from DESU, we expected that you would be doing so many things in order to make the system efficient. So whatever steps you have taken certainly would have affected the cost of electricity to come down. So can you throw some light whether the electricity cost to the consumer has come down or it has really increased? That is the first question for me, sir.
Thanks for raising this very important question.
Second point, just let me.
Okay, you have more questions?
Yeah. Second was, are you thinking of any going to the cloud roadmap for the internal applications in BSES? That is the third question. Third thing is, sir, the man per megawatt ratio is now 0.5 per megawatt. You said 1, but recently it has come from the government that we should go for further reduction. I am from NTPC Limited.
Okay.
So we have been told to go for 0.5 manpower reductions.
Sure.
And APDRP is one of the projects which is being done by the states. So whatever steps you have suggested here are already there in the APDRP for the states to be implemented. Automatic metering, all those things are happening. I mean, maybe the pace is slow, but of course they are also going for this APDRP programs in states, and some states have already come out very fast in that. So I would like.
I'll not be able to remember so many questions. I'll take the initial ones.
Yeah, you can choose your question. I think there were a lot of them for the audience.
I'll forget
For the benefit of the audience, you can
the
take
first
one.
question, if I remember right, you said, has it impacted the overall cost of service to the consumer, right? 2002. You see, in our the distribution business, three components make up our total tariff. One is the power purchase cost. You know, we buy the power, so we are just a retailing company. We buy them and we retail it to our end user. So the power cost, which includes generation, transmission, and scheduling cost. All three put together is the power purchase cost. The second component is my O&M cost, which has got three components: employee expenses, repair and maintenance, and administrative and general expenses. Okay, that's for the vehicle and other, breakdown cars and other things. So the last is the financing cost. It has two components. One is three components: depreciation. Two is return on equity. Third is your interest cost. So that makes up the total cost. Now, the power purchase cost is determined by the Central Electricity Regulatory Commission. So whatever NTPC provides us, we have to pass it on. So that's the component we receive. There's nothing much we can do there. As far as the O&M cost is concerned, where I contribute, 2002, my price was 63 paisa per unit. Okay. In 2012, in spite of the inflation, in spite of all that escalations which happened, and my investment into the technology and things like that, the cost has come down from 63 paisa per unit to 60 paisa per unit. So it's reversed the inflation, right? That's as far as the O&M is concerned. The financing cost, when you put capex, the depreciation will go up, and your return on equity depends on how much you plow back into the business, and your interest charges also depends on how much is your debt. So that's not in your company. So effectively, the prices of power has gone up because the power supply cost has gone up. Say, for example, in 2007, the NTPC used to deliver power to me at 1 rupee 81 paisa per unit. Today, NTPC delivers at 5 rupees 17 paisa. So all those efficiency gain in terms of loss reduction, technology, is all got sucked away there. We didn't have a commensurative kind of a revision on the retail level. To a certain extent, those efficiency gain could be managed. It could counter that escalation in the generation cost. But we couldn't absorb all of them, so the cost had to go up because the power purchase cost is high.
Can we have one more question?
Yeah.
I just recommend you to stick to one short question because we're running out of time, and as much as I want good questions, I don't want lengthy questions. Just one question.
Yeah, my name is Naresh Gar. Just a short question. I heard you saying that pump utility is the maximum power consuming, about 50%. You pumping of the oil or the water.
Yeah.
It's consume about, and you have developed a very simple device.
Yeah.
And it is on the renewable energy source. So if you can have some plan, maybe along with the government, to implement this or popularize this can save lot of power immediately, which is much needed by the country.
Very.
So that's a comment. All right. Is there a question here? Yes, please.
Sir, the theme of this summit is cloud computing.
Yeah.
And
Yeah.
we tap electricity from grids.
True.
And the concept of cloud computing was borrowed from electricity grids. Now my question is, did our BSS go for cloud computing?
Yes. We have. And not just for our own application, even for the MIDAS which we have developed, okay? When we are offering this solution to other utilities, we are providing cloud computing for them. You know, everything is hosted in a cloud and they are able to access them, okay? And on a per user basis, we have a charge there. Yeah.
Any more questions?
A last one. It's not even a question.
Oh, it's not the last one. I'll decide that. But I would recommend a question. If you don't have a question, I'll ask you to hold back. We can come to comments later. A question.
Yeah, Ramesh.
But please keep it short.
Very,
Please
very
go.
short question. How much percentage of operational cost do you see cloud computing kind of implementation can reduce? or
Thank you.
impact?
I've been wanting to ask that question. Thank you.
Okay. How much of operating cost it will bring down?
Yeah.
Yeah, I'll just give you an example. My employee cost was around 47 paisa in 2002, and with all this cloud computing and IT enablement
Per
things like
megawatt.
that, per unit,
Per unit. Okay.
47 paisa per unit
Okay.
was my employee cost. It's come down to 35 paisa in 2012. That is after the 6th pay commissions, after all those revisions, and the salaries have only gone up. Of course, my volume of business has also gone up. But, you know, a lot of people took voluntary retirement, a lot of people moved to other sector. I could manage with the available resource.
So that's the cumulative effect of all
Yeah.
reforms that you've done.
You know,
Right?
I will not be having precisely
Yeah. All right.
ballpark.
Well, we could take that up as a separate study for myself.
Yeah.
Any other short questions? Yes, sir.
Yeah.
This is
I know-
from AEG. I just want to know, sir, that the installed capacity, you said that it's almost 205 gigawatt, but the grid demand is 125 gigawatt. Is it the capacity of the grid, or how this figure? It's almost 60%.
Yeah, you see, you have an installed capacity in the country close to about 210,000 megawatts. But the maximum power, which is handled by the 5 regional grids, you know, 4 of them integrated, one is yet to be integrated, but they have a tie link. The 4, the north, east, west, and northeast are integrated. South is yet to be integrated. It's expected by 2014. So there, the entire power handled in the grid system is just 1,35,000, 25,000 megawatts, maybe 30,000. That's the peak, because we have not invested that much on the transmission side or on the downstream distribution side. See, I'll tell you, there are pockets of surplus because there is not enough wires or transformation capacity at the distribution side to take that power to the end user. You have Gurgaon, just adjoining Delhi, in darkness, or they're using DG sets. If I have surplus, I can't push the power to them because they don't have enough corridor to take that power there. So there is no compulsion or pressure on any of the state utilities to actually ensure that they create capacities. So, you know, unless you have capacities, these generation are getting bottled up, you know, and that could be a very disastrous thing for all those investors on the generation side.
So we have time for one more thing. Sir, you wanted to make a comment. So this is the time for the comment because we'll close after this.
I have a question.
Sorry, sir, there's someone in line before you. I'm sorry, there's someone behind in making a comment. Go ahead.
It's a very quick one. I think I must admit, and so would everyone agree, that since Rajdhani Power has taken over, there have been a lot of improvement in the billing and hardly any mistakes. Of course, the rates have gone up, but that's not what we are talking about. Could
You know
someone
why
please-
the rates have gone up?
You talk to NTPC for that.
So, okay, my observation is, or my suggestion is, can we do something to improve Delhi Jal Board? I know it's not relevant to you, but that's one of the most horribly managed.
All right, point well taken. Thank you very much.
Thank you.
Okay, thanks for an excellent presentation. My question is, I'm sure that when you took over from Resu, at that time you have the employees you took over were a lot of training, etc. would have gone to really improve that. But today, now, what is your plan that how are you really augmenting your manpower requirements, and what are the steps you are taking so that they are up to the mark and they are productive from the day one when they
Sorry,
join us?
I'm really sorry, I'll have to interrupt. That's a very good question, but that's outside the cloud computing theme here, and we're running out of time.
No,
so
in terms of the training, if you are providing training,
I
within
appreciate the
cloud
question. I
computing,
really do.
definitely it is
All
very
right.
much relevant.
Answer. It's a very important aspect. We insist and we ensure that every single individual, whether from the legacy or from the new system, they all have to necessarily go through at least 15 days of training, every year. So this is a minimum which we have to ensure, but everyone at least goes through a month's training. So we invest a lot on training and development.
I'm sure there are a lot more things which we can't talk about right now. Thank you very much, sir. I think you're one of the few CEOs who is so very well clued into IT that the CIO's job becomes really easy. From my side, for your time and effort, here's a small token of appreciation.
Oh, thank you.
Thank you very much.